Hi everyone, my name is Rosário Fernandes. I'm a mobile app developer at a company called Most Devs, and I'm a Firebase Google developer expert. Uh, More recently, I've started to enjoy contributing to open source, and one project that I've been contributing a lot during the last months is called Firebase KTX, which is the one that I'm gonna talk about today. So before we start, let's just make sure we're all on the same page. So you guys are probably asking what is Firebase. In short, Firebase is a platform that allows you to build apps. It basically provides you a backend for your app. I think you guys, I think everyone knows or has heard of this term called backend as a service. So Firebase is one of those platforms where you can get like a database, an authentication system, hosting for your app if it's a web app. You can get a service to upload your files, where users can upload their files and everything else. So this is the list of tools that Firebase provides. Most of them, they're available for Android, web, and iOS. And on Android, they're available through an SDK, which is the Firebase Android SDK. And this SDK was written in Java, but I believe you guys might have heard that that last year Google said at I/O that Android is now Kotlin-first. So since Kotlin provides interoperability with Java, this shouldn't be a problem for us. I mean, it's fine to use Java SDKs on Kotlin code, but the problem is that they may not always look like Kotlin when you use them. So that's why we came up with the Firebase KTX libraries. But before I get to the libraries, let me just tell everyone that the views and opinions that I'm going to share here today are my own. So if you ask Firebase team about these libraries, they probably have different views and different opinions. What I'm sharing here is all mine. So here's an example of what it looks to use the Java SDK. Basically, you have a builder there. I think this is very common in Java. But if we use it with the Kotlin, with the Firebase KTX libraries that we built, this code becomes shorter. So this basically shows what was our purpose when creating those libraries. We were trying to make it more concise, maybe a bit shorter, more idiomatic for the Kotlin language. So in order to do that, we used a few of the Kotlin language features. Here's a list of them. I'll be going through each one of them during this presentation, showing you how to use them and how we actually use it to provide you with the new libraries. So first of all, we have Kotlin extensions, which is the main feature that allowed us to create the library. I mean, the library is called KTX, which actually stands for Kotlin extensions. So we couldn't have done it without this. It basically provides us with the ability to extend a class without having to do any kind of inheritance from it. And you guys can see here an example. For example, we could extend the string class to add one more property called last char, which would obviously give us the last char from that string. We could extend another class, let's say rectangle, and we could add a function to that class to get us the area of that rectangle. And as you guys can see, when we want to use these properties or these functions that we added to the class, we use it just as if it was part of the class, when in reality it isn't. It's just an extension that we created. So the second feature that we used is called object declarations, which allows us to declare a class using the singleton pattern. The object keyword in Kotlin is widely used. We have object declarations, we have companion objects, and there's also an object for using interface. But in this case, we're using the object declaration. We did a pretty simple thing, which was just declare object Firebase, and this class has no methods, no properties or anything. But that's because we actually added the methods as we added the functions as extension functions, which we'll see up ahead. So here it is. We declared a property called database, which will call the original Java SDK, which was Firebase database.getInstance. So instead of having to call all this, we would just call Firebase.database, and that would return us with the instance from Firebase database, and the same for Firestore. And we have a different get instance, which actually requires us to pass in a Firebase app. So for that, we created an extension function called Firestore. And here below, you can see how to call those functions. Next, we have inline functions. In short, adding inline to a function basically tells the compiler not to treat our function as a higher order function. What happens in Kotlin is basically functions are usually considered as objects. So you can pass them as parameters and do anything else you can do with an object in Kotlin. So what happens when you do that is you're actually telling the compiler to, if you don't use inline, the compiler will basically treat your function as an object, and obviously it will allocate some memory to store your object. So by using inline, we're telling that we're passing a function as a parameter, but don't treat it as don't allocate memory for it. Instead, when you're compiling it into Java, just copy the function as it is to the bytecode. And this slide shows an example of a function that we have, where we pass another function as parameter. And as you can see on its usage, here we have the to string, it's user1, and then for the function we use a lambda expression. So we're passing a builder to it, and this is how it looks. I'll explain more about this ahead. And then we have reified type parameters. They basically allow us to access a type passed as parameter. As you can see here, we have declared a function. It's inline, because reified actually requires you to inline your function. We're basically converting a document snapshot to a different class. It's kind of like a test, but this is very specific to Firestore. So if we used it normally, we would do, with the Java SDK, we would say like data snapshot to object, and then as you can see, we're trying to convert it to the person class, and you can see this is not so good looking, I think. While if we use this extension that I created here at the top, we can simply pass it as a typed function. So then we have type-safe builders, which allows us to create Kotlin-based DSLs. For example, we could have in Firebase SDK, there's one specific library called Firebase Dynamic Links, which allows us to create dynamic links, and we can have parameters we can add parameters to that link. Some of them specific for Android, some of them specific for iOS, and some different other platforms as well. And for that, we created a type-safe builder, which is that first example that I showed you earlier. As you can see, instead of having to use the Java builder, we simply use a builder that is shorter and more idiomatic for Kotlin. Next, we have destruction declarations. This is maybe one of my favorite features on Kotlin. So take a look at this example on the top. We're adding a progress listener to an upload task. Let's say we're uploading an image or a file. We might want to check the progress of that upload. So for that, we have the snapshot as argument to that listener. So we can access the bytes transferred, we can access the total byte count, and then we calculate the progress using this simple formula. Now, when using destruction declarations, we don't really need to separate those. Instead, we just specify it here that we're using the bytes and we're using the total count, and then we can use those variables directly. We don't really need to access the snapshot. How did we do this? Here's the code. We basically create a function called component1 for the first variable. We have component2 for the second one, and so on. And note that this is an extension of the task snapshot class, which is the type of this snapshot that is passed as argument. Next up, we have sequences. At first, I thought this feature was missing, but turns out that Kotlin already provides a function called the sequence, which can convert an iterable or an iterator to a sequence. I'll explain a bit of what sequences are. So in Kotlin, we have the same collections that we have in Java, but with the addition of sequences. So sequences is also a kind of a collection. The only difference is that its multi-step processing is usually executed lazily instead of eagerly, which is the method used in lists or any other Java collection. So I'll show you an example. Let's say we have this list of words, and we want to execute some operations on it. So we could use a filter to filter out all the words that have length greater than 3. We can map those words to its length, and then we only take 4 of those words. So let's see how the whole process works. So first you have the filter. So you're getting the whole list of words. After going through the filter, we are only getting the words that are greater than 3. So we have those words here, like 5 words. So after mapping it to its length, you can see here we're mapping each word to its length, and then we only take 4 of them. So this is basically around 23 steps. Now, if we use a sequence instead, as you can see here, we're splitting this string and then converting it to a sequence. The sequence will only run the operations once it finds what we call terminal operation. All of those are intermediate operations. So filter, map, and take are intermediate. So it's the same process. As you can see, we are filtering it by length and then mapping to its length and then taking 4. Now this will be different because because it is lazily done. As you can see here, we'll call the filter. The doesn't count because it's not its length is not greater than 3. So we go to the next word, which is quick, and quick is fine. So we stick with quick, and then we do the mapping. We map it to 5, and we take it because we're supposed to take 4. We haven't taken on, so we're taking 1. That's fine. We go to the next word, which is brown. Its length is greater than 3. That's fine. So we keep it. We map it to its length. Here it is, and we take it as well because we haven't taken more than 4. Next, we go to the word fox. It doesn't match the filter criteria, so we go on to the next one. We have jumps. It does match it. We do the same process, and at the end, we take it. Next to the next word, we have over, and over does match it. We map it, and then we take it. And since we've already taken 4, those remaining words will not be processed. So as you can see, this is a few less steps than the previous example where we're using a collection. Okay, so now that we spoke about the features that are present in the SDKs, there are a few ones that are not, and those are coroutines, flows, and silk classes. So I'll be talking about this next. First, we have coroutines, which are called lightweight threads. As you may know, Android recently deprecated some of the APIs that they were using for background processing, such as async tasks and services. So coroutines are one of the ways that you can replace those. I would say coroutines are similar to what other languages have, such for example JavaScript, they have async await. But instead of this, in Kotlin we don't have those keywords. Instead, we have suspend functions, and obviously it's a way to escape callback hell. So let's see this in action. When we use Cloud Firestore, we could be reading from a document. Let's say we're reading somebody's data, and then up next we want to read from a different collection or a different document where we would get the list of friends from somebody else. So since we're reading from 2 different references, we would probably need 2 different listeners, and those listeners usually execute asynchronously, so we couldn't just separate them. We would have to nest one inside of the other in order to access both values that are being read. And as you can see, if we had like one more listener, we would be nesting and nesting and nesting to a point where it becomes really callback hell. So using coroutines, let me just show you. Using coroutines, we don't need that. We can simply write all of our code as if it was synchronous. So this would mean we would have here our document. We would call get on it, and then use this extension function called await. Also notice that this is a suspend function because coroutines can only be used using suspend functions. We'd call await on the first reference, then await on the second one, and this way we could use both results. And as you can see, there are no listeners. We're not nesting anything. It all looks like synchronous code. And then to use this, usually suspend functions need to be called from a coroutine scope. So just as an example, I'm showing you how to use the global scope to launch a coroutine. So where does this await method come from? It comes from the Kotlin X coroutines play services library. So this is basically a library maintained by the Kotlin team, and it basically provides you with some extension functions which you can use to use the tasks APIs with coroutines. So the await function here comes from that library. Next up, we have asynchronous flow. In short, asynchronous flow returns multiple asynchronous computed values. So it's kind of like coroutines, but instead of returning one value, you would be returning multiple values. So let's see a simple example. Let's say we have a list. There's this is a simple list with 3 elements, and we're going through each value and showing it to our user. Sounds pretty simple, but what if we had to pre-compute these values? We could, for example, use sequences. So for each value, here we're using a sequence builder, and then for each value with maybe use sleep. Let's say we're computing it, we're doing some huge computation thing here, and then yield the value so that the main function can take it. But the problem with this approach is that it blocks the main thread. So how can we not block the main thread? We could use a suspend function, right? So we would use a coroutine to maybe compute this value. As you can see here, we're using run blocking, and then it might take a while to compute, but at the end, it will return a list. And since we're returning a list, this means we would have to wait for it to compute. So if you have here delay, if each operation takes 1 second, it means it will take like 3 seconds to compute it all. So a way to solve this problem, instead of waiting for all the values to be computed, we can use a synchronous flow. So it's basically the same code as we've seen before, but now we are using the flow builder, and every time we finish computing an element, we emit it. So on our main thread, we would be collecting each value that is being emitted from the flow. So that means every time one value is computed, we would have it ready for us while we wait for the next values. So this is the main advantage of using Flow. Now, how do we use it with Firebase? There's been a lot of discussions on this GitHub pull request. So I would recommend taking a look at it. So basically, the main suggestion was to use this builder called callback flow, and the problem with callback flow is that it's still experimental. So that's why this feature isn't yet available on Firebase KTX. But if you're interested in trying it out, I totally recommend that. And this code is actually provided on that PR. So you can simply go there and maybe copy it and try it for yourself. Next up, we have sealed classes, which are used to represent restricted class hierarchies. So this is basically like an enum for those of you who are familiar with object-oriented languages. So we could have, for example, a sealed class called result, and the result can have different types. It could be a success, it could be an error, or maybe it could tell us that it's still in progress. Sealed classes are mostly used to represent states. So here's how we would use it. Just like an enum, we get the result and we check what's the state of that result, if it's a success, error, or in progress. One of the main advantages of sealed class over enum is that the compiler already knows what are the possible types of this result. So for example, if in this when expression, if we had missed one of the conditions, the compiler would ask us to either fill in that condition or maybe use an else branch to treat those values. So you really can't have one state that is not handled on a when expression. So how could we use sealed classes to simplify the usage of the real-time database, for example? So one method that I really don't like on the real-time database is this child event listener, because it's an interface with five functions. And if you're creating a child listener, you actually have to declare all of those functions. And as you can see in this example, I'm only using the child added function. All the other functions have empty bodies. I'm just interested in logging the child added, but I still need to write all the other functions. Maybe we could improve this using sealed classes, and we could create a sealed class called child, and then we would have some subclasses that say added, changed, removed, moved, canceled. Those are just, it's one for each of the functions that we had here. As you can see, we had added, changed, removed, moved, and canceled. So once we have this, we could use it with flows. So that means that we would add the listener. This is an extension function called children flow. I'm not so good with names. Maybe we could come up with a different name for this. But then every time we have a new event, let's say a child added, we would offer a child, our sealed class, dot added, the subclass, and then we would pass it those parameters from the onChild added function. Same would go for the other ones, onChild added. I've omitted the two methods to fit everything on the slide. And in case there's an error, we could close the flow with that error. So how does it look now? We basically have the our reference. We call that extension function that we created called children flow. And now we simply collect all the events that are coming from this flow. So we have our child, we check if this is a child added, and we simply log it, which is what we were doing in the first one. Notice how short this is compared to the first example that I showed you. So we no longer need to have all of those functions. So here's a few extras. So those are not really, I don't think those are big changes, but there are small ones that can help in a way. So if you're using Firebase performance monitoring, there's one interesting function that I found on this blog post by Part. It basically starts a trace with a name and then stops it at the end of the function. So you can go ahead and read that blog post. It's really nice. Then we have a second one that I find interesting. I actually had proposed this to the Firebase team, but they went instead with type-safe builders to match all the other existing functions. But this one is a bit different because it uses the Kotlin pair builder. So let me show you what it looks like. It basically allows you to use the to keyword to set custom keys to Firebase crash lyrics. And I feel like this is maybe a bit better than using the type-safe builders. I've linked here some additional resources which you can use. I'll be sure to share this presentation with you at the end of the talk. And that's all from me. Thank you very much, and I hope I can answer some questions now.